Alright, we've got another lesson here on the Pythagorean Theorem. We're going to talk about how you can use the Pythagorean Theorem to help you find distance on the coordinate plane. It says find the distance between the 2 points. So we got point 1 and point 2 here. And this is a diagonal distance, so we can't just count the number of units because it's a longer distance than if you were just going straight down or straight across. If we're going straight down and straight across, obviously we just count the number of units. But that's not how it works with diagonal distances there. They're going to be longer than just if we went straight down or straight across. So we're going to use the Pythagorean Theorem to help us find this. What we're going to do is we're going to take this diagonal distance here and we're going to create a right triangle from these points as well. So we're going to come straight down from the top point until we're level with the other point. And then we're going to go straight over to meet the other point there. And that's going to make a right triangle for us. And now we can use the Pythagorean Theorem, with this being the right angle, to help us find the length of this missing side. Obviously this side right here, there's going to be the longest side, so it's going to be side C. So it says, once we make the right triangle, write the lengths of the two legs. So to find the lengths of the legs, all we're going to do is count the side lengths using what we see on the coordinate plane. So you can basically just count using the spaces we have here. So 1, 2, 3, 4 for this side right here. And then for this side, 1, 2, 3, 4, 5, 6 for this side. And then this is the side we're looking for. We don't know, so just label it C. Okay, and then it says, find the distance between the points using the Pythagorean Theorem. Now, if you need to know the steps for using the Pythagorean Theorem, you're going to go back and look at the previous lesson. And I'm not going to go through all those. I didn't write down all those steps again this time. But I'll talk you through them here a little bit, and we'll solve this. So these are obviously the two legs that make up this right angle. So we can label one of them A and the other one B. It doesn't really matter which one we label A and which one we label B, but we're going to plug those into the Pythagorean Theorem now. So we have a value for A, we're going to call that 4 squared, plus B is 6, so 6 squared equals C squared. So once you plug the numbers into the Pythagorean Theorem, then you square the numbers. 4 squared is 16, 6 squared is 36, equals C squared. And 16 plus 36 is going to give you 52 equals C squared. And then that's what C squared is. We want to know what just C is. So we have to undo the squared by taking the square root of both sides. So the square root of 52. And we probably could take some time to estimate the square root of 52, but we're going to be using calculators on this today. So we could estimate without a calculator, but you're allowed to use calculators on this today. So second, and then to the left of the 7 there is our square root button, 52. And we're going to go to the nearest tenth with this today. So 7.2 is this length right here. And it should be the longest side. And you don't have to put anything, just 7.2 units, because we're not measuring with feet or centimeters or anything like that. So that's basically it today. We're going to do a little more practice with this right now. But that's it. I mean, we're basically just going through these steps, making a right triangle from the 2 points, writing the length of the legs, and using the Pythagorean Theorem from there to help us figure this out. So let's take a look at number 1 here. We're going to make a right triangle, come straight down from the top, the point that's highest, come straight down to level the other point, and then straight over to meet it. Write the lengths of the legs. So this is a length of just 2, and this one is 1, 2, 3, 4. And then label that longest side, the side we're looking for between the 2 points, that's side C. So it doesn't matter which one you have as A and which one you have as B. You could do 4 squared plus 2 squared equals C squared, or 2 squared plus 4 squared equals C squared. So you could do it either way. So it's 2 squared plus 4 squared equals C squared. 2 squared is 4, and 4 squared is 16. Square the numbers. So then you add them together. 4 plus 16 is 20. 20 equals C squared. And then you just take the square root. Square root of both sides. So C equals whatever the square root of 20 is. Second, I'll do this here where you guys can see it. Second, and then the square root, and 20. So 4.47. Now the 4 has a 7 next to it. You gotta look at that second number, decide if it's gonna round up or stay the same. This is going to round up to 4.5 because the number next to it is 5 or more, so 4.5. You gotta make sure you round correctly with these, so C is 4.5 on that one. Let's do a few more here. Number 2. This is the highest point there, so we're going to come straight down with that one until we're level with the other point, and go straight over to meet it, making a right angle right there and giving us a right triangle. The Pythagorean theorem only works for right triangles. So this is a side length of 1, 2, 3, 4, 5, 6, 7 down here. Side length of 1, 2, 3 here, and this is side C. So we have the lengths of our two legs, A and B. Let's go 3 squared plus 7 squared equals C squared, and you could switch that up and write 7 squared plus 3 squared if you wanted to. A and B can be switched up. You just have to make sure that the longest side there, the hypotenuse, is always side C. 3 squared is 9. 7 squared, 7 times 7 is 49, equals C squared. Add those together, you get 58 equals C squared. But that's what C squared equals, so we want to finish by taking the square root of both sides. So let's type that in and see what we get here. So second square root of 58. 7.61, that'll just stay 7.6. All right, we're on a good roll here. Let's take a look at the backside. Let's flip over to the backside, and we'll save this one for class. Let's take a look back here, and let's do a couple of these. So on these, you just have these 2 points, and we're looking for the distance between these 2 points on the coordinate plane, but you don't have a line drawn between them. So what do you think the first thing we're going to do here with these is going to be? We're going to draw a line between them. So go ahead and connect point 1 and point 2. I'm looking for the distance between those 2 points. And then from there, we're going to draw the other lines on here that make up the right triangle. So come straight down from that top point and straight over to the other one to meet it. So the only difference with these is that you have to draw the line between the 2 points first to find this distance. So this side right here is 1, 2, 3, 4, 5, 6. We know it's going to be longer than 6 here on the hypotenuse. 1, 2, 3, 4 for this side. And this is side C. So it's going to be high 6s or low 7s probably. It could be the distance between those. Let's find out. So A we'll say is 6 and B is 4. So 6 squared plus 4 squared equals C squared. 6 squared is 36 and 4 squared is 16. 36 and 16 is 52. So 52 equals C squared. And then we got to take the square roots of those. So square root, second square root of 52, 7.2. I think we had that one already today. So 7.2, that 1 there is not big enough to move that up, so 7.2. All right, and then for the next one here, we're taking a look at the distance between these two. Let's go ahead and draw that line there between those two. Okay, go to the highest point there and come straight down until we're level with the other point, and then straight over to meet it. Looks like we have side lengths of 1, 2, 3, and side lengths of 1, 2, 3, 4, 5, 6. So we got 3 squared plus 6 squared equals C squared. And again, you could switch that up and write 6 squared plus 3 squared. 3 squared is 9, 6 squared is 36, equals C squared. We're going to add those together and get 45. 45 equals C squared. And then we finish by taking the square root to cancel out the squared. The square root of 45. Second square root, 45. That gives us 6.70. So that's definitely not big enough to move that up. So just 6.7. I think that's enough practice there. We may do these in class, these other ones in class, or we might not. We'll just kind of see how things go in class. But it gives you a way to find distance between 2 points on the coordinate plane using the Pythagorean theorem. We'll see you guys in class.